Good afternoon, everyone. Good afternoon, everyone. I'm very happy to see you here in my presentation today. My name is Jeongho Hyeon, the first author of this paper, and I'm integrated PhD course student from Yonsei University in South Korea, and I'm a member of the Smart Infrastructure Lab, and my supervisor is Professor Hongjo Kim, and today my title is Evaluating Load Segmentation Performance in Participatory Sensing, Investigation into Alternative Metrics. So my presentation will be delivered with four main sections. First is overall introduction of my paper, and second is proposed method. Third is experimental result, and brief conclusion of the paper. So one of the primary reason is the sorry. The first, the primary reason, one of the primary reason is the rising cost in the maintenance and repair region, and sorry. So let me explain the motivation behind our research. One of the primary reason is the escalating cost of the road maintenance. In South Korea, the total expenditure on road maintenance was $2 billion in 2015, but just in 6 years later, it had skyrocketed to $2.9 billion in 2021. So this indicates that the increase of the nearly 50% in maintenance cost. So furthermore, previous studies have highlighted the impact of proactive M&R on reducing maintenance expenses. This underscores the urgent need for more efficient monitoring of road conditions, enabling early problem detection and a potential of cost savings. Currently, the road surface surveys are carried with expensive equipment and limited specialized personnel, making frequent monitoring challenging. Therefore, alternative methods are being explored. Previous studies used dashboard camera images to detect road cracks, but the MIOU score achieved was around 60% only, which is challenging for practical application. So the IOU score, also known as intersection over union score, is a metric used to evaluate the performance of a segmentation model. In the context of our task, the segmentation model predicts whether each pixel in an image represents a crack or belong a background. To understand the IOU score, let's imagine overlaying the predicted cracks and the real cracks on the image. The IOU score measures how well these two sets of cracks align or overlap with each other. It calculates the ratio of the intersection to their union. So the IOU score provides an objective measure of how closely the model's predictions match the ground truth. So for the example case shown on the right, the union is 7 and intersection is 1. So IOU score is calculated as 1/7. And let's explain the experiment we conducted. So we use the popular model name is DeepNet Plus, which is known as being good at crack segmentation task. So check out these two pictures. The left one is a shot from a car dash cam, and the right one shows where the actual cracks are and how they look. So the objective of our segmentation model is to find these cracks in the dashcam images. So, all right. So let's play a little guessing game. You see these two pictures here, right? So the left one, the left image is the prediction from the model, and the right one is the ground truth from the human manually labeled. So do you remember the IOU score we talked about earlier? So what do you think our model's prediction IOU score in this picture? So green pixel means the crack. So 50% or over 70% or so. But you might think that our model is doing a pretty good job, but surprisingly, the actual IOU score of the model is only 0.28, which indicates that there is a big gaps between the prediction and ground truth. This made us realize that there is a discrepancy between what we identify with our eyes and the IOU score implies, thereby questioning the adequacy of IOU score as the metric for road crack segmentation. So I developed a new evaluation metric name is GPS crack prediction score. But however, due to the complexity of the CPS process, so I will only provide an overview of the key idea behind this metric in this presentation. So why is there this gap between what we see with our eyes and what the IOU score shows to us? Well, it comes to how wide the detected cracks are. Let's assume a person labeled the crack as being 1 pixel wide, but our model predicts it's 4 pixel wide. Because of this difference, the IOU score just only 0.25. But when you think about it, that small difference in pixels doesn't really matter when you are trying to identify cracks in the real world. So here's the main point. Instead of focusing too much on pixel level prediction, we really need a way to evaluate overall shape of the cracks. That's why we brought this method called CCQ. By creating a buffer zone around the real cracks, it provides some flexibility. A few pixels of here and there are acceptable. So this second method is key point matching. The approach is reduce sensitivity and pixel thickness. And the experimental results show that IOU scores in the low, but new metrics was we proposed provide more human-like evaluation. This comparison indicates that the proposed method in this study are indeed effective. So same. So this the main contribution of this paper is introducing new evaluation metrics for road crack segmentation, highlight the limitation of the IOU score. Thank you for listening.